Our lesson on 5.5 is going to have you solve quadratics by a method called completing the square. Now, what's kind of unique about solving quadratics is we're going to learn several different methods, and for any given problem, you might be able to solve it 4 or 5 different ways. But on your quizzes and your tests and your homework, I'm going to ask you specific ways to solve specific problems, so you got to know how to do them all. So this lesson is all about completing the square. So first, when I say I'm going to complete the square, it means I'm going to take a trinomial and I'm going to rewrite it in a way so that it can be written as a perfect squared binomial. And we'll see what that means in a second. But the idea is that if the number in the middle with the x is called b, then the number off here to the side, the third, the constant number, is half of b squared. And the reason we want to make sure that happens is because this trinomial will end up factoring into this lovely format right here, and then it's going to be really easy for us to solve. So what we're going to do is we're going to take half of the b term and then square it to find the c value. So when I look at number 1, we're going to take half of our b term, which is -8 divided by 2, half of it, and then we're going to square that number. So -8 divided by 2 is -4, and -4 squared is a 16. So the c value is really a 16 for this problem. So if I rewrite this as x squared minus 8x plus 16, then we can take this, which is now a perfect trinomial, and rewrite it as the square of a binomial. Now the way the pattern works is this, you just write down x first, and then the next number to come in this binomial is half of your b term. So half of -8 was -4. In other words, we're taking this perfect trinomial and factoring him. And the reason he factors so pretty is because of all the work we did to find the c value. So we're going to do the same thing here on number 2. We're going to take half of our b term, so -3 cut in half, and then we're going to square that. Now unfortunately, -3 over 2 is a decimal or a fraction. It's always better to leave these as fractions unless it's an application problem. So -3 halves squared is going to be a 9/4. So we're going to rewrite this as x squared minus 3x plus 9/4. And then because of all that hard work we just did, this is going to factor really beautifully. It's going to factor into x, and then half of your b term would be a minus 3 halves quantity squared. So for number 3, half of our b term, 26 divided by 2, and then we're going to go ahead and square that. So that's 13 squared, which is 169. So this trinomial becomes x squared plus 26x plus 169, and after all that, this is really easy to factor. It's going to factor into x, and then half of our b term is a plus 13 quantity squared. Okay, so next we're actually going to solve using our completing the square method. Our process of finding the value for c and then rewriting it as a square of a binomial, that's all going to come into this next section. So here's your steps to success when you're solving with completing the square. First, you want to make sure that the x squared's coefficient is a 1, and if it's not a 1, we're going to have to possibly divide by a constant. Then we're going to rewrite the equation in the form x squared plus bx, and we're going to add blanks to each side. We'll see what that means in a second. And then we're going to find the value of c by taking half of b and squaring it and adding it to each side. Then we're going to factor, and then we're going to solve by taking the square root. It sounds like a lot of steps, but it's really not that bad. So first, I'm going to notice that the x squared has a coefficient of 1, so step 1 is done. The next thing it says is to write it in the x squared plus bx form. So what that really means is the ax squared, or the x squared, and the bx stay on the left-hand side. But then we're going to move this 3 to the right side, so we're going to end up with a plus 3 on the other side. Now it also mentions that we're going to add blanks. Alright. So what I've done is I've just added the 3 to the other side of the equation, and I've left blanks. And these blanks are going to be for our c value, which is what we're going to find in step 3. Remember, c value is half of b and then squared. So if I take half of 10, which is 5, and then square it, I'm going to get a 25. And I have to add it to both sides in order to keep my equation balanced. Now you should notice, we're on step 4, it says take this and factor it into a binomial squared. Well, x squared plus 10x plus 25 factors into x and then half of b, so plus 5, squared. And then over here on the right hand side, we can just simplify that by adding those together. 3 plus 25 gives us a 28. And now this is going to be really easy to solve. We're going to square root both sides, just like what we did in section 5.3. And we end up with x plus 5 equals, now don't forget the plus or minus because it's an equation. And when I reduce the radical of 28, he's really like the square root of 4 times the square root of 7. So it's 2 square roots of 7. And then your final answer is when you subtract the 5 to the other side, you get negative 5 plus and minus 2 square roots of 7. So kind of a ugly answer in your eyes, I'm sure, but it's clean enough for us for Algebra 2. The process of solving by completing the square is a little complicated, so let's practice it a few more times. Okay, number 5. The first coefficient's a 1, so we're good there. The next thing we're going to do is we're going to rewrite it by moving the constant over, and we're going to leave blanks for that c value that we're going to add to both sides. Okay, this 8 came from adding the 8 to the other side. So now we're going to find our c value by taking half of our b term, well half of 6 is 3, and then squaring it. So a 9, and we're going to have to add it to both sides to make this work. Now you're going to take this trinomial and factor it, and we're going to add these together at the next step. So x squared plus 6x plus 9 becomes x plus 3 quantity squared, and then 8 plus 9 is 17. And then solve just like we did in 5.3. So we're going to square root both sides, and we're going to have x plus 3 equals plus and minus. Now the square root of 17 does not break down, so I'm just going to leave that as a square root of 17. And then your final step would be if you were to subtract 3 from both sides, you get negative 3 plus and minus the square root of 17. And we're done. Moving on to number 6. First coefficient is a 1, so we're good to go. I'm going to add, this time subtract the 4 to the other side. And at the same time, I'm going to leave blanks for the c value we're going to come up with. Alright, our c value would be half of negative 12, which is negative 6, and then when I square that, I get a positive 36. The c is always going to be a positive number because we're always squaring it, which leaves you with a positive answer. Now when I go ahead and I factor this left-hand side, x squared minus 12x plus 36 becomes, careful, x minus 6 squared, half of your b, and then negative 4 plus 36 is a 32. And now when we square root both sides, I get x minus 6 equals, now 32 breaks into square root of 16 times square root of 2. So we're going to end up with plus and minus 4 square roots of 2. And our last step would be, whoops, to add the 6. So our final answer is x equals 6 plus and minus 4 square roots of 2. So far these answers haven't been real pretty, so I'm thinking there's only a couple of methods I could use to solve these quadratics and get, you know, a clean answer that wasn't a decimal, and that would either be completing the square method or something called quadratic formula, which we're going to learn in the next lesson. Okay, our next problem actually already did that part of the first and second step. First step is taken care of because our first coefficient's a 1. They already took the constant to the other side, so all I'm going to do is figure out what that c value has to be, so I can add it to both sides. So half of 14 would be 7, and then 7 squared is 49. So next, when I rewrite this trinomial, it's going to be x plus 7 quantity squared, and then negative 57 plus 49, let's see, that gives us a negative 8. Okay, now this is just like something in section 5.4. We're still going to square root it, but if you remember from section 5.4, when you square root something that is negative, you got to think about introducing the number I. So we still have plus or minus. When I break down negative 8, I'm going to say it's a square root of 4 times the square root of negative 1 times the square root of 2. So that's going to reduce to plus and minus 2 I square roots of 2. And then our final answer would be if I subtract that 7 over, I'm going to get a negative 7 plus and minus 2I square roots of 2. Alright, so just like so many things that we do in this class, every lesson kind of builds on the previous lesson or lesson or two before it. So you really have to know what you're doing in the previous lesson. So let this be a little lesson for you. If you had trouble in 5.3 or 5.4, it would be best if you came in and got help on that first before you tried to tackle 5.5. Okay, number 8. We're going to have to add that 1 to the other side, and at the same time I'm going to kind of leave a blank for the C value. Okay, now unfortunately on this C value, he's going to be a fraction, because if I cut 5 in half, that's 5 halves. And then when I square a 5 halves, that's not anything pretty, so we're going to leave it as 25 fourths. Alright, so on the left-hand side, this is going to factor into x, and then half of 5 would be 5 halves, so plus 5 halves squared. And then 1 plus 25 fourths, that's like taking 4 fourths plus 25 fourths, so that would be a 29 fourths. Okay, we're going to go ahead and square root both sides. Now on the left-hand side, you have x plus 5 halves, plus or minus on the right-hand side. Now if I square root of 29 fourths, I want to think about taking the square root of the top and the square root of the bottom. Well, the square root of 29 is nothing pretty, but the square root of 4 comes out to just a plain old 2. So our last step would be to subtract the 5 halves to the other side. So we have negative 5 halves plus and minus the square root of 29 over a 2. Now if you notice, these have common denominators, so your ACT would not want you to write the answer broken apart like that for this particular problem. They would probably have you write it as one numerator with one common denominator. So you'd probably write negative 5 plus or minus the square root of 29 all over 2. So I like either one of these answers. I'm not going to tell you that one's better than the other, but if you're taking a multiple choice test, you don't have the option to control how the answer looks, so you might have to look for an equivalent answer to what you have. Okay, the next section, you're going to notice the first step in these problems is not done. The coefficient for x squared needs to be a 1, and right now he's a 3. So what we're going to do is we're going to divide everybody by a 3. And when you divide everybody by a 3, your new problem is x squared minus 2x plus 4 equals 0. And now we can handle this like any other problem that we were completing the square on. So we're going to move the 4 to the other side by subtracting it, and I'm going to leave a blank for the c's. So half of negative 2 is negative 1, and then if I square that, I get a positive 1. So here on the left-hand side, when I factor that, I get, careful, x minus 1 squared. Then on the right-hand side, you get a negative 3. So we're going to square root both sides. And we get x minus 1 equals plus or minus. I can't break down the square root of 3, but I can pull out the I because it was a square root of a negative. So plus and minus I squared to 3. And then your final answer, when you add the 1 to the other side, is 1 plus or minus I squared to 3. Alright, moving on. Number 10, I need that coefficient to be a 1, so I'm going to go ahead and divide everybody by a 5. I can do that because this is an equation. So my new problem is x squared minus 2x plus 6 equals 0. And now we're going to solve it with the rest of our steps. So I'm going to subtract the 6 over, and at the same time, I'm going to leave a blank for all my c values. Well, half of negative 2 is negative 1, squared is positive 1. Here on the left-hand side, this factors into x minus 1 squared. Negative 6 plus 5 is a negative, or plus 1 is a negative 5. And now when I square root both sides, there's not much simplifying I can do other than to pull out the I. So we get x minus 1 equals plus and minus I square root of 5. And then your final answer, when you add the 1 to the other side, is a 1 plus and minus I square root of 5. Alright, nice job. And our last section is going to have you take a standard form parabola, and we're not solving. What I'm going to have you do is I'm going to have you rewrite this in vertex form. And just to jog your memory, vertex form was this guy, where it was x minus h squared plus k. So it, instead of being, foiled out, it was in a more factored form, and that was called vertex form. So we're going to use some very similar techniques, except instead of moving things to the other side of the equation, I'm going to keep everything on the right hand side of the equation, and we're going to think about other ways to keep things balanced. So first thing I'm going to have you do is we're going to kind of separate the ax squared plus bx away from the constant value. So I'm going to do x squared minus 8x. I want you to put a plus blank down, just like we did. And then off to the side, we still have a plus 11. But then think about another way to keep this equation balanced. If I add a number to the right-hand side, instead of adding a number to the left-hand side, the other way to keep it balanced would be to simply subtract that number from the same side. If I was to add a 4 and then later on subtract a 4, it's not going to affect the value of the equation. So now let's think about our numbers. For c, it's going to be half of your b term and then squared. So half of negative 8 is negative 4, squared is a 16. So if I add a 16 here and then a couple steps later I subtract a 16, that's fine. That's going to work great. Now I know what you're thinking, well, if you add 16 and subtract 16, wouldn't they just cancel each other out? We're going to selectively group parts of this equation together. I'm going to have you group these first 3 together, and I'm going to have you group these last 2 together, and let's see what happens. So we have y equals this trinomial right here, x squared minus 8x plus 16, factors, because I chose that 16 for a reason, into x minus 4 quantity squared. And then over here, 11 minus 16, if I push those together, I get a minus 5. I think we're done. This is the equivalent form of that equation, just in vertex form. So the other thing they wanted me to do was find the vertex itself, and remember the vertex is at hk, and h is always opposite, so my vertex is at 4, negative 5. So not too bad. I actually kind of like those problems. Moving on. Same idea. We're going to move the 9 a little off to the side so we can group him later with something else. But I'm also going to leave a blank where I add the c value, and then I'm also going to subtract the c value. So let's find that c value. Half of this would be 3. 3 squared is 9. Now, kind of unique circumstance here. Our second group's going to end up canceling itself out, but that's okay. The first group we're going to rewrite in factored form. So we have x plus 3 squared, and then negative 9 plus, or positive 9 minus 9 just cancels out to a 0. So if you put a plus 0 here, that's fine. You don't need to have it though. So here's our vertex form, with or without the 0, I don't care. And our vertex for this quadratic is located at negative 3, comma 0. Okay, our next problem, same way. We're going to kind of move the 8 off to the side a little further, and we're going to leave a space where I can both add and subtract the c value. Alright, so here half of negative 4 is negative 2. When I square that, I get a 4. So I'm going to add the 4 and subtract the 4. I'm going to group these first 3 together. I'm going to group these last 2 together. And that's going to give me y equals, let's factor that first group, x minus 2 squared, and then 8 minus 4 gives me a plus 4. So there's vertex form for that quadratic, and the vertex is located at 2, comma, 4. And then for our last problem, more of the same. So we're going to push the negative 3 off to the side, and we're going to leave blanks for our c value. We're going to add the c value, and then later on we're going to subtract the c value. So half of 12 is 6, and when I square that I get a 36. So when I group my first group together, and then the last group, I get y equals x plus 6 squared, and then negative 3 minus 36 is a minus 39. So there's our vertex form, and the last part of the question says the vertex is at negative 6, negative 39. Nice job. That concludes the lesson on 5.5, completing the square.